All right, so this is 2.4b, so part 2 of the chain rule. So the first one we have is f of x is equal to x squared, square root 1 minus x squared. And so how could I rewrite this square root thing?
To the power of 1/2.
To the power of 1/2. And so now I could rewrite this as x squared times the quantity 1 minus x squared to the power of 1/2. And so what rule are we going to use when I take a derivative here? Oh, eventually chain rule, but before we actually get to chain rule, what is this? This is a product. So guess what we're going to use? The product rule. So let's do it. And so how do I notate taking our derivative? F prime of x. And so how do we do product rule? The derivative of the what? The first. So what is the derivative of the first? 2x. And then times the second. So now I have 1 minus x squared to the power of 1/2. And then what? Plus. Now I need to take the derivative of the what? The second. So what needs to be brought out front, Emil? 1/2. And so now I have 1 minus x squared to the power of negative 1/2 because I subtract a power. Now, we need to know the chain rule though. So does anything pop out? Yes. So negative 2x pops out. And so there's my derivative of my second. But now I need to multiply it with what?
By x squared.
By the first, which is x squared. All right. Before I even do this one, let's talk about factoring again. If I have x squared plus 2x, what could I factor out of that? An x, right? I'd factor out an x. And then what would I be left with? X plus 2. Everybody knows how to do that. That's good. However, what we did is we subtracted the power. So we subtracted the power of 1 from each of these. So 2 minus 1 is really what? X to the power of 1. And then if I subtracted a power of 1 again, that's really x to the power of 0. And so it kind of went away because it's power of 0. So now we're going to use that same technique on this. But before we do that, we're going to simplify this up a little bit. So 1/2 times negative 2x times x squared. What does that become? Negative x cubed. And so then I have negative x cubed. I still have a 1 minus x squared to the negative 1/2. And I still have a 2x times 1 minus x squared to the power of 1/2. And so now we're ready to factor. So when I'm looking at this 2x and this negative x cubed, what could we factor out? An x. And then this is the harder part for you for now. So if I have 1 minus x squared to the 1/2, and then I have 1 minus x squared to the negative 1/2, what could I factor out? I always need to factor out the least power. So the negative 1/2 power. And so now I have 1 minus x squared to the negative 1/2 power. I always factor out the least power. And so now we need to talk about what's left. So I took out an x from a 2x, so what's left there? A 2. Now I took out a power of negative 1/2 from a 1/2. What do you do with the powers? You what? You subtract them. So now I have a 1/2 minus a negative 1/2, which is now a power of what? 1. And that's the whole reason behind why you do it. And so now I have 1 minus x squared to the power of 1. Now I factor out an x from a negative x cubed. So what am I left with? Negative x squared. And then I took out a negative 1/2 power from a negative 1/2 power. So I'm left with 1, essentially. And so I don't need to put that. All right, and so that's when we factored. So now we need to combine and kind of simplify this up. So what could we do with this 2? Distribute it. So now I have 2 times 1, which is 2, and then 2 times negative x squared, which is negative 2x squared, and then I still have a minus x squared. All right, so now we're ready to put what's up top and what's on the bottom. And so who gets to stay up top? And x gets to stay up top. And who else gets to stay up top?
2 minus 2x squared minus x.
2 minus how many x squareds?
Negative 3x.
Negative 3x squared. All right. And then it's all over. This guy goes to the basement because it's a negative exponent. And so really a 1/2 power is really a what? A square root.
Okay.
And so now I have the square root of 1 minus x squared. Let's look at this next one. So now we have f of x is equal to x over the cube root of x squared plus 4. So could we use the quotient rule?
I think we could.
You could. However, I'm going to tell you it gets really disgusting. If you're actually really good at algebra, maybe you could do the quotient rule. However, I would venture away from the quotient rule on this one. All right, so I'm actually going to do a product rule by manipulating this up a little bit. How could I manipulate this, kind of bringing this denominator up top?
It'll be negative 1. Yeah.
It would be an x times what? X squared plus 4 to the negative 1/3. This is actually going to be a lot easier technique than actually using the quotient rule. All right, so let's take a derivative. So how do I notate taking my derivative? F prime of x. All right, and so now how do we do this? The derivative of the what? The first. So what is the derivative of the first? 1 times x squared plus 4 to the power of negative 1/3. And so now what? Plus the derivative of the second. So what's the derivative of my second? What gets to be brought out front? Negative 1/3. And then I have x squared plus 4 to the power of what? Negative 4/3. Now, does anything pop out?
Yes, 2x.
2x pops out. And so there's the derivative of the second, but then I need to multiply by what? The first, which is x. And so there's the calculus. That's it. All right? And so that's the easy part. And so now let's simplify this up a little bit. And so now we'd have 1 times x squared plus 4 to the power of negative 1/3. And then what does this negative 1/3 and this 2x times x combine to?
Negative 2/3 x squared.
Good. And then I still have x squared plus 4 to the negative 4/3. All right. And so now we need to factor out our least powers. Okay. However, this one's a little bit more difficult than the last one because now I have a 1 and I have a negative 2/3. What could I factor out if I have a 1 and a 2/3? Hint, I kind of look at this denominator. I need to factor out a 1/3. Exactly. Brilliant. All right. And so I'm going to factor out a 1/3. Okay. Now, before we even get started on that, I kind of want to just talk about it. When I factor out a 1/3 from a 1, what am I going to be left with? I'm dividing, right? So 1 divided by 1/3 is really multiplying by 3. Exactly. And so that's why we can pick that guy. All right. And so now when we look at these, I want my least power. And so what's my least power? Negative 4/3. So now I'm going to factor out this x squared plus 4 to the negative 4/3. And so now let's talk about what's left. And so I took out a 1/3 from a 1. So what am I left with? A 3. And then I took out an x squared plus 4 to the negative 4/3 from a negative 1/3. So again, guess what I'm left with? An x squared plus 4 to the power of 1. Okay, because I'm taking minus a negative 4/3. So I'm really adding 4/3. So negative 1/3 minus a negative 4/3 is really what? Positive 3/3, aka 1. All right. And so now, what am I left with? I have 1/3. I take it out from negative 2/3. So now I'm left with what? I factored out a 1/3 from a negative 2/3. So what's left? Negative 2. And I still have x squared. And so then I just took out a negative 4/3 power from a negative 4/3 power. So those cancel. So I'm just left with that. All right. And so there is our algebra. So now what are we distributing? A 3. So now I have 3x squared plus 12. And then I still have minus 2x squared. All right. So now let's talk about who gets to stay up top. So how many x squareds get to stay up top? I got 1x squared and then plus 12. And then who goes to the basement? A 3 and then times x squared plus 4 to the power of 4/3. And there. So this one, we got y is equal to the quantity of 3x minus 1 over x squared plus 3, all raised to the power of 4. So what is my innermost function?
3x minus 1 over x squared.
Exactly, that whole quotient. Exactly. And then what's my outermost? To the 4th. Exactly. All right. So eventually I'm going to have to take the quotient rule. All right. Even though I don't want to, we have to. All right. All right. So how are we taking a derivative? dy dx. So what comes out front? a 4. So now I have a 4 times the quantity of 3x minus 1 over x squared plus 3, all raised to the power of 3. Okay? So that was my outer. That was my shell. Now I got to get to my milk chocolate. So now I have to take the derivative of what? The inside, which is a quotient. So what rule do I have to use? The quotient rule. So how do we do the quotient rule? The derivative of the what? The top. So what is the derivative of the top? 3. So we got 3 is the derivative of the top, and then times x squared plus 3, and then minus the derivative of the bottom, which is 2x, and then times the top, which is 3x minus 1, all over x squared plus 3 quantity squared. All right. So now that is the calculus part. The rest is going to be algebra. So let's distribute the 3, and then we're going to distribute the negative 2x. So we end up with 3x squared plus 9, and then minus
6x squared.
and then plus 2x. Love it. All right. So now let's start combining things. So up top, we'll end up having how many x squareds? Looks like a negative 3x squared plus 2x and then plus 9. Awesome. So now I end up having this 3x minus 1 quantity cubed, and I have x squared plus 3 quantity cubed. And so I still have this 3x minus 1 quantity cubed, and I still have the 4 up top. However, this is an x squared plus 3 cubed, and I have an x squared plus 3 squared, and so that becomes an x squared plus 3 to the power of 5. All right, because we add those powers when they multiply. All right, and so now I have dy dx is equal to that. All right, so this page is basically, hey, we need to remember our note card. You guys are more than welcome to use your note card on these, but we also have to remember the chain rule. So let's go. So we got y equals sine of 2x. So what is my outer composite of sine of 2x? Sine. What is my inner composite? 2x. All right, so how do I notate this derivative? dy dx is equal to, what's the derivative of sine? Cosine of 2x, but then what pops out by the chain rule? A 2. All right, and if you do this enough times, you kind of leave a space here instead of putting it at the end. You can just put them right out in front, and then you don't have to rewrite it again. All right, let's do the next one. So now we have y equals cosine of x minus 1. So again, how do we notate taking our derivative? dy dx is equal to, what's the derivative of cosine? Negative sine of x minus 1. However, by the chain rule, what pops out? A 1. So do I need to put it? No. So that one's kind of convenient. All right, let's do it again. So now I got y equals tangent of 3x. And so what is my outer composite? Tangent. My inner composite is 3x. So now when we take our derivative, we got dy dx is equal to, what's the derivative of tangent? Secant squared of 3x, and then what pops out by the chain rule? A 3. So we need to talk about these parentheses and the differences and commonalities that they might have. And so if I have the cosine of 3x squared, that really means the cosine of 3x squared. And so when I take a derivative, my outer is cosine and my inner is 3x squared. Is everybody following me? Right. And so what's my derivative of cosine? Negative sine of 3x squared. And then what pops out is a 6x. Make sense? Cool. This one is cosine of 3 times x squared. Cosine of 3 is a number. All right, it's very similar to -1. It's really close because 3 is close to pi. And so if we remember our unit circle, 3 is right here, and cosine is the x value of that. And so it's really close to -1, but it's just a number. So it's a constant multiple. It's kind of like 2, but it's really close to -1. And so this one, I would take a derivative of x squared, which is what? 2x. And so then I would end up having just this 2x cosine 3, or 2 cosine 3 times x. That's kind of how I would actually probably put that one. All right, so if you see where this squared is on the outside of this 3x. This means the 3x is getting squared. And so you kind of have to distribute your squaring on that one. And so this is really like cosine of 9x squared. All right, and so then the derivative of cosine again is negative sine. And then we end up having our derivative of 9x squared, which is 18x, and we go from there. All right, part D and E is where students mess up a lot of the times, so hopefully this doesn't happen. So when we say cosine squared x, kind of like Yamil talked about yesterday, we should think of what? Cosine of x squared. It's the same thing here. If I have square root of cosine x, that's really cosine of x to the 1/2. All right. So these two, kind of think of it on the outside, okay? So your innermost composite is cosine, your outermost composite is the squaring part of that function. And so when we do that, we bring down the 2, and then we have cosine, and then you have to remember the chain rule, and we go from there, all right? So that's how we go about that. However, you don't have to just limit yourself to one chain. We can have 2 chains, or 3 chains, or so forth, all right? Yes, it is a wrapper. All right, got f of t. It's not my favorite variable, however, it's used all the time. And then I have sine cubed of 4t. And so I want you to think of the peanut M&M here. What is my outermost composite on this sucker?
Sine. No, cubed.
Cubed. Cubed is the outermost. Then, what's my milk chocolate? Sine. Then what's my peanut? 4t. Okay? And if you have to rewrite it, rewrite it. So this is like the same thing as like saying sine of 4t all cubed. Okay, that's the same thing. All right, so let's go. So now we notate our derivative, f prime of t is equal to what comes out front?
3.
A 3. So now I have a 3 sine what?
Of 4t.
Squared of 4t. And so now we take the derivative of what? Sine. And so what's the derivative of sine? Cosine of 4t. And so then what pops out by the chain rule? So now I take the derivative of what? 4. 4t, which is 4. And then we just simplify this up a little bit. And so we got 3 times 4, which is 12 sine squared of 4t times cosine of 4t. And so there is our derivative. All right, so page 137, numbers 24, 28, 32, 34, 43, 44, 47, 49, 79, 92, 95, 101 through 104, and 109. And you are a superstar.